Hello, good evening. So, the students who have joined, can you please let me know if my voice is clear and the video is visible, and also if my screen is visible to you? Please write in the chat box if my voice is audible and the screen is visible. Okay, so we will wait for a few minutes, then, after everybody joins, we will start our session. So, good evening, students. I will wait for a couple of minutes, then I will start the session. Meanwhile, you can write in the chat box if the screen is visible and the voice is audible to you, or if you have any problem listening to my voice or seeing the presentation. Okay, we will start once a few more students join. So let's wait for a couple of minutes. Okay, so very good evening to the students who have joined the class. My name is Moshumi Dev and I am the PMRF Fellow from the Department of Chemistry and Chemical Biology, IIT ISM Dhanbad. So this is the tutorial class for the NPTEL course of Medicinal Chemistry. Today it is the week 4 live session where we will discuss the problems related to your week 5 course content. Okay, so we will discuss like every day 15 to 20 questions, 20 MCQs which is related to your week 5's topic, and something little bit outside of topics questions also are there, but it will help you to understand the course better and to learn it more closely. And if you have any doubt, anything, you can write in the chat box. Okay, at the end of every question I will take the doubts from you and I will try to solve those doubts. And anyway, if you still have some doubt, you can just write a mail to me. I will share my email id at the end of the session. And one more thing, regarding last day, somebody had dropped a mail to me regarding the assignments, so the weekly assignments which have been given to you. I think for week 4 it was. So it was related to one question. So I checked up, so there was some typographical error, I think. But what happened, like these questions are set from the NPTEL side, okay? And the professors actually send these questions to the NPTEL website and they put it up on this, so like that. So it will be better if you have some question or something mistakes related to the assignment. It is better to raise the question in the NPTEL forum. So there every in if you go to the SWAM website, there is an online forum where you can just write up the errors which are given in the assignment. So if there are any assignment error in the assignment or anything, so it is better if you write the error or the problems there, because it will directly go to the professor in charge of the course, and he will correct it automatically, because I cannot correct it from your behalf. Okay, so it will be good if you do it in this manner. So anyway, I think if there is something error, you will be given marks for the question, or because if it is wrong anyways. So okay, so let's start our meeting. If anybody joins in between, I will just add him or her. So I hope my voice is clear and the video, the slides are visible to you. So you have any problem by looking the slides or listening to my voice? If you have, you can write in the chat box. Otherwise, I will start the session. Okay, I assume there is no problem. Okay, so let's start. Okay, so the first question, it says that what is the molecular target for the Vinca alkaloids used as the anti-cancer agents? Your options are number A, tubulin, number B, transport protein for serotonin, number C, DNA, and number D, cell membrane. Okay, yeah, thank you. Everything is okay. So the first question was it, and I want you to, everyone, to try this to answer this question. You can try it and write it on the chat box. Okay, so the first question was, I will repeat it once more. What is the molecular target for the Vinca alkaloids used as anti-cancer agents? Your options are like this: tubulin, option A. Option B is the transport protein for serotonin. Option C is the DNA. And option D is the cell membrane. So you have to identify the correct option. Okay. You can just try it and write it in the chat box. I will just discuss the answer and everything like every day. But it is better if you can try to answer it by your own. Okay, so we have one answer and it says tubulin. Okay, so let's see what is the correct answer for this. So yes, the correct answer is tubulin. Okay. So, so this is the Vinca alkaloid, which is a natural product. As you can see, it is the structure is very complicated, and you don't need to remember any structure for any. I think this kind of complicated natural products. Okay, so you don't need to memorize it. But you should know, like the alkaloids and natural products are generally of this kind of complex structure. So that's why it is very difficult if you go into the lab and try to synthesize the natural product. It is very difficult because the structures are very complicated, and as you can see, there are so many chiral centers. I mean, the nature can fix this chiral center very easily, but by synthesizing this kind of molecule in your lab, it is very difficult. Because you have to fix so much, so many chiral centers and all. So it is very difficult in that phase. So, anyways, so what happens, like in this alkaloids, these natural products, they are used as an anti-cancer drug, and the target is the tubulin. So the tubulin or microtubules, so what happened, like now when there is a, this is the microtubule, okay, the tubulin have the microtubules, and this is the free tubulin dimers. This is a reversible reaction, okay. This can stay as this free tubulin dimers, or it can stays as this microtubule. So what happened when there is a, this Vinca alkaloids are added, what will happen? This alkaloids will bind in the tubulin dimers. Okay, and what will happen? Their paracrystalline aggregates will form. So normal mitosis, as you know, there is a cell division and there is a mitosis happen in a cell division. So there is a phase called metaphase. Okay, when the spindles of the chromosomes are formed. Okay, and the tubulin and microtubulin, the molecules, they are stacked to form mitotic spindle. Okay, and this mitotic spindles, what they help in the anaphase, your anaphase, which is the third phase of your a cell division, like prophase, metaphase, anaphase, and telophase. So in the anaphase, there is a spindle formation, and this tubulin molecules, they are stacked to form this mitotic spindles. Okay, but what will happen if this kind of alkaloids are given? So what will happen? The mitosis is blocked by this Vinca alkaloids. Why? Because the tubulin molecules, they fail to polymerize in presence of Vinca alkaloid. Okay, and in presence of Vinca alkaloid, this tubulin molecule will fail to produce this microtubule, and okay, this will fail to produce this kind of microtubule. And what will happen if these microtubules are not formed? The mitotic spindle will not be formed, and the cell could not cannot go to the anaphase. Okay, and what will happen? The dissolution of the mitotic spindle leads to the cell death. Okay, so for the anti-cancer, as we know, there is a two kind of cell, which is normal, our normal cell, and what is the malignant cell. Okay, so the malignant cells are the reason for the cancers, and this kind of anti-cancer target with alkaloid, they actually produce the cell death for the anti-cancer, and acts as an anti-cancer agent. Okay, so I think it is clear to all. So at any part of the any session, today's session, if you have any doubt, anything, as every day, you can write in the chat box. Okay, at the end of session, I will try to answer all those queries. And anyway, I want you all to answer every question at the end of the every question. Try to answer the questions at the when I am showing you the questions, because in that way it will be better for you also, or for me also, to learn. Okay, so I think this is your problem 1, and I will go to the problem 2. So problem 2, it says that the following structure is used to treatment brain tumors. So what is this structure called? So number 1, it is carmustine. Number B, lomustine. Number C, streptozotine, and number D, cyclophosphamide. So you have to. So I have, in the previous question I have said, like you don't need to remember any complicated structure of natural product, but as you are learning medicinal chemistry, it's always better to for you to remember few structures of few drug molecules. Okay, like and the structures which are very simple, but yet you have to I think know the name of some few drug molecules and the main core of that drug molecules. So this is one drug molecule, and it is used for the brain tumor treatment, and you have to identify which is the correct name of this structure. So try answering it in the chat box. Okay, and again we have an answer. Lomostril. Okay, let's see. Okay, let's see the answer. So yes, the correct answer is Lomostill. So as I said, it is always better to for you to remember few structures and few names, because since you are reading medicinal chemistry, it is important to you to know what is the few common drugs and common things. You don't need to memorize the structure of the huge natural products or alkaloids anything, but simple drug molecules it is you must remember. Okay, so Lomostill it is also said as this INN. So it is an alkylating nitrosourea compound which is used in chemotherapy, and it is closely related to the semestrin and is in the same family of the streptozicin. It is highly lipid soluble drug. Thus, it crosses the blood-brain barrier. Okay, we will learn about blood-brain barrier. What is it, and in the later slides. Okay, and this property makes it ideal for treating brain tumor, which is its primary use. Although it is used to treat Hodgkin lymphoma as the second line option. Okay, so as I said you like you need to remember few drugs. So let's say what are the other drugs. Okay, so like this first one, the carmustine, it works by slowing the stopping the cancer cell. Okay, and this is the structure of it. Okay, streptozocin, it is the antibiotic that produces pancreatic inlet beta cell destruction, and the cyclophosphoramide used to treat cancer of the ovaries, breast, blood, and lymph system. Okay, so this molecule, this cyclophosphoramide, is kind of important because these are very extensively used for the treatment of the cancer, and it will be better if you can remember this structure also for the cyclophosphoramide. And as you know, that for the treatment, so when the drugs are given, so there is a very important I think there is a very important characteristic of the drug, like it should not cross the blood brain barrier. So all you know, like there is a in our brain there is a barrier which is so maximum drugs, they do not cross that blood brain barrier. Okay, and it is very important to design a drug which are not meant for brain, not to cross the blood brain barrier. But if you are targeting to synthesize a drug which is actually for the brain tumors or brain cells, then it is very important, like this kind of drugs must cross the blood brain barrier. Okay, and this molecule which is your lomustine, it is a very highly lipid soluble molecule, and thus it is able to cross the blood brain barrier easily. Okay, so it will be good if you can remember this simple structures, and this one is particularly very important, the cyclophosphoramide, because it's very extensively used in the cancers. Okay, so I think it is clear to you. And anyway, at the end of the session, this slides and PPT and the video of today's session, everything will be communicated to you by the NPTEL website. So you don't need to worry about if you cannot see the slides for the network problem and anything. But try to be there during the session and try to answer few questions. And if you have any problem, you can always write to the chat box. Okay. So now we will go to your next problem. Okay, so problem number 3, it says that what is the mode of action for the anthracycline anti-cancer agents? So your options are as follows. Number A, alkylating agents. Number B, chain cutting agents. Number C, antisense agents. And number D, intercalating agents. So you have to identify which is the mode of action for the anthracycline anti-cancer agents. Okay. Try to answer this question in the chat box. Okay, again we have another answer, intercalating agents. Okay, so let's see. Others also try, because it will be better if everybody tries to at least please try. If it doesn't matter if your answers are right or wrong, but at least you should try, because that's how you will learn much better. Okay, it doesn't matter if your answers are correct or wrong, but if you try, it will be better for you only, uh, to see if you have learned the things better or not. Okay. Okay, let's see the answer then. Okay, so the correct answer is intercalating agents. Okay, so this is the, okay, let me just draw it out. Okay, so this is your intercalating agents. Okay, so this intercalating agents, as you can see, this is the anthracycline anti-cancer agents. Okay, so anthracyclines, they are not only used for the anti-cancers, they are also used as sometimes as antibiotics. Okay, so like tetracycline. So this is this anthracycline, as you can see, the structure. This is a common structure for the anthracycline. Okay, there are four rings. Okay, this four ring, this middle three, first is A, B, C, and D, and this B, C, and D ring are basically like the anthracene molecule. As you know, what is the structure of the anthracene? Very common molecule, as you know, like from this anthracene, this anthracyclines are the name has been derived. So, okay, my drawing is again bad. Okay, anyways, this is three six-member rings and three six-member benzene ring kind of structure. This is aromatic. So this is the your anthracene. Okay, as you can see, this is like this middle part, it is like this anthracene, and there is another ring. So there are four rings, A, B, C, and D. And as you can see, for the anthracycline kind of molecule, what happened, like with this A chain, so there is a sugar type of molecule. Okay, this is a sugar moiety. As you can see, this is a sugar moiety, this is a sugar moiety, this is a sugar moiety. Okay, so there are few examples. So again, I have said you don't need to memorize, literally memorize the structures, like of which group is where, which group is not where. But remember the rough structure, the pharmacophore of the molecule. Okay, so this is a rough structure. There is four six-member rings together joined. So that much you have to remember. Okay, so there are few examples, like there is doxorubicin, there is daunorubicin, so there is aclasinomycin. Okay, so this kind, so I will suggest you to just remember also the names of the compounds. Okay, so you may be given the name of like a drug, let's say like doxorubicin, and you have been asked what is the class of the compound where it belongs. Okay, so then you need to remember, okay, it is the anthracycline type of anti-cancer drug. Okay, or another thing which can be given, like you are given this structure only, and you are said to write the class of the anti-cancer drug. Okay, so you need to also that's why you need to remember this few structure. So what is let's see the properties of these drugs. So anthracyclines are tetracycline rings. So these rings are called the tetracycline. There are four rings, so this is called as tetracycline. So these tetracycline rings with the sugar uh, daunosamines. So this sugar is called the daunosamine. Okay, so they are DNA intercalating agents that block the synthesis of DNA and RNA, and the agents are primarily toxic during the S phase of the cell cycle. And doxorubicin is probably most important anti-cancer drug available because it is relatively broad spectrum of the activity. Okay, so these things you know that this is the structure of the doxorubicin, this one, this second structure, this one also. Okay, so this is very important because it is has a broad spectrum broad spectrum activity. And also you have to remember, like, these agents are toxic during the S phase of the cell cycle. So you know there are many phases of the cell cycle, like M phase, S phase, and G phase. So we will learn it later in the course, but you remember, like, these compounds are toxic to during the S phase of the cell cycle. Okay, and they block the synthesis of DNA and RNA. So this was your problem 3. Okay, now we will go to your problem number 4. Problem number 4, it says that diminished delivery of oxygen to the tissues is termed as number A, hypoxia, number B, ischemia, number C, homeostasis, and number D, metabolism. So you have to identify the correct option, like what is the diminished term which is used as for the diminished delivery of oxygen to the tissues. So anybody have given the answer in the chat box? Okay, we have two answers. Who says this is hypoxia? Okay, let's see. Okay, so correct answer is your number A, hypoxia. Okay. So when we are reading about the hypoxia, will read about the other terms too. So what is a hypoxia? So it is a condition in which the body is deprived of adequate oxygen supply. Okay. So what will happen, like when you have this kind of a situation, so the alerted brain, okay, the brain sends signals to the rest of the body, like your body is having the oxygen deficiency, and what will happen, the breathing rate will increase, and the constricted vessels in the lungs, the lungs vessel will be constricted, okay, and increased heart rate, the heart rate will be increased, and dilated peripheral blood vessels in the arm, legs and the feet, and your arm, legs and feet will have the dilated peripheral vessels, okay. So this is the condition called the hypoxia. So what are the other options, other condition means, okay. So for the first one, okay, so ischemia, so it is a state of the tissue or organ has its arterial perfusion lower relative to the metabolic needs, or ischemia is defined as a condition of the inadequate blood supply to an area of the tissue. Okay, so it is an inadequate blood supply in the part of the body, even in the point of the complete deprivation. So it is defined as a condition of inadequate blood supply. So it is the diminished delivery or inadequate delivery of oxygen is known as hypoxia, whereas the inadequate blood supply or the deprivation of blood supply to any tissue is known as a ischemia. So what is homeostasis? So it is a condition in which the internal environment of the body remains relatively constant despite changes in the external behavior. For example, this would be the maintenance of the body temperature and levels of the glucose in the blood. Okay, so in the homeostasis, what will happen? The condition in which the internal environment of the body remains relatively constant despite changes of the external environment. And what is metabolism? As we all know, it is the sum of all chemical reaction which is happening in our body, the anabolic or catabolic. So what is the anabolic reaction? They use chemical energy to synthesize product. And what is the catabolic reaction? They break down substances to generate chemical energy. Okay, so there is a about all about the metabolism. So as I said, when you are learning something, okay, so when you are solving this kind of MCQs, you know, the knowing the correct answer is important, but knowing of all the others about all the other options is also important, like which is the other options mean, because question can be come from this hypoxia, it can come from ischemia or metabolism or homeostasis also. So it will be when you are solving some MCQs or anything, try to learn about the options also, okay. Just don't identify the correct answer and stop there, okay. Learn about what the other options mean, especially when there is something like some molecules or some kind of the terms involved. So try to know everything, because the next time the question can come from the other terms or other options too, okay. So this was a relatively easy question. Now we will move toward our next problem. So problem number 5, it says that, yes, somebody wants to join. Okay. So we will move toward our problem number 5 now. So the problem number 5, it says that the following antibacterial agent was used during World War II. What is the name of the structure? Number A, erythromycin. Number B, chloramphenicol. Number C, proflavin. And number D, rifamycin. Rifampicin. So you have to identify what is the name of the following structure. And anyways, you also need to know what are the other structures and other names have the structures, okay, and we will discuss it obviously. So first try to answer this question. Okay, so anybody has answered it? Okay, we have same answer. Okay, it is good like everybody is trying to answer the questions because otherwise there is no point of the class. Okay, so I will suggest everybody to try to answer the questions. It doesn't matter if it is correct or wrong, but at least you should try. Okay, let's see. Oh, okay, so good. The first correct answer is proflavin. Okay, so proflavin is a topical antiseptic agent used in the wound dressing to prevent infections, and this is the structure of your proflavin. So as I said, it is better for you to learn what is the structure of the other compounds when there is any new term is involved and what is it is used for. Okay, so this is the structure of the erythromycin. So erythromycin is also a very macrocyclic compound. Okay, so with so much of the chiral center, so it is a very important antibacterial agent. Okay, so the erythromycin is used to treat certain infection caused by bacteria such as infections in the respiratory tract, including bronchitis and pneumonia. And as you know, erythromycin is a very common drug which is used for us when we have something bacterial infection. Okay. Okay, so chloramphenicol it is used to treat serious infection in the different parts of the body, and it is the structure of the chloramphenicol, and it is a relatively easy structure. Okay, and the last one, the rifampicin, so it also have very complicated structure. Okay, and it is a class of medications called the antimycobacterial, and it works by killing the bacteria that cause infection. So these are the structures, very important structures of all the very important antibacterial agents. And so this question is given as for the proflavin. So sometimes it can be happen like you are given this structure and you ask what is this compound and what is it used for. So that's why you need to remember some of the common drugs. Okay, so this was question number 5. Now I will move toward your question number 6. Okay, so your question number 6, it says that what are the main enzyme system for catalyzing ethanol to acetaldehyde? Your options are number A, ADH. ADH is for alcohol dehydrogenase. Number B, it is called ADH, CYP2E1 and catalase. Number C, only CYP2E1. And number D, only catalase. Okay, so like last questions, try to answer this in the chat box. Write the which will be the correct answer for this question, and which is you think to be the correct answer, and we will discuss the system and the reactions in detail. But first you try to answer this question. Okay, so during any time during the session, if you don't see the screen or you have difficulty listening to my voice, you can also write in the chat box because there may be internet disruption from my side also. So make sure if you have any problem, make sure to write it out. Okay, so my voice is breaking. So right now it is fine or it is still breaking? There might be an internet issue. So others, is my voice is clear or it is breaking? Hello? Yeah. Okay, no problem. So if you have doubt, if you cannot listen to my voice, you just write here, okay? Because sometime it may happen like due to internet disruption, you cannot, the internet problem can also be from my side also. So I will then check it. So I think it is clear and there are some answers for the question. So okay, others try a few minutes again to answer this question. I will discuss it anyways. So, what will be the main enzyme system for catalyzing ethanol to acetaldehyde? So, the conversion of ethanol to acetaldehyde, it is what kind of reaction? The reaction of ethanol to acetaldehyde. So, is it oxidation, is it reduction, or is it what kind of reaction it is? You know, it's very simple, like from ethanol to aldehyde. So what kind of reaction it is? Is it an oxidation reaction, or is it a I mean reduction reaction, or it is a any other type of reaction? Okay, try to answer this also. What do you think? Ethanol to acetaldehyde. What is the changes happening in the molecule? If you write the structures, what is the structure of ethanol? What is the structure of acetaldehyde? And what is the reaction? Okay, what it happens? So you know, na, the structure of ethanol, it is like CH3, CH2, and it is OH. It is the structure of ethanol. What is the structure of acetaldehyde? It is CH3, it is C double bond O, and there is a H. So from this to this is what kind of reaction? Is it oxidation or reduction or any other kind of reaction? Okay, it is oxidation reaction. Very good. Okay, so let's see what is the correct answer and how the reaction happens actually. So the correct answer of this question, the main enzyme system involved in catalyzing ethanol to acetaldehyde is ADH, CYP2E1 and catalase. These three take parts in this reaction. Okay. Okay, I will just erase this one. Okay, 1 second. Okay, it is not getting erased. Okay, anyway, let's discuss this. So this is the reaction of the ethanol to your acetaldehyde. So as you can see, there is a ethanol molecule like CH3, CH2OH. Okay, this picture is I think little bit hazy, but this is it may be looking hazy during your presentation. But when I will share this slides, this PPT with you, it will be clear. Okay, so try to see. So this is the ethanol molecule, and there is a thing called which is involved here, which is called the NAD plus. Okay, and when ethanol is getting oxidized to this acetaldehyde, this NADH, it is getting NAD plus, it is getting reduced to your NaH. Okay, NADH, and the only one proton of the ethanol is absorbed and added to the specific site of this NAD plus, and other proton is coming up here. So as you can see, there is a CH3, CH2, OH. So there are total number of 6 proton, and here we have total number of 4 protons, CH3 and H. Okay, so there are two hydrogen is missing. One hydrogen is taken by this NAD plus molecule and is converting to the NADH. Another hydrogen, it stays as the H plus. Okay, so this is the alcohol dehydrogenase is a very specific enzyme for this kind of reaction. So dehydrogenase means two hydrogen atoms will be abstracted from the substrate. Okay, so it is an NAD plus dependent cytoplasmic enzyme. It oxidizes ethanol to acetaldehyde, and ADH is a dimer and has 6 isoenzymes. And in some individuals, the enzyme is mutated. In such individuals, alcohol metabolism is lower, and even small quantity of alcohol may produce the symptoms of intoxication. Okay, and when this enzyme is absent, so this is the complete reaction. What happens? Ethanol is getting converted to the acetaldehyde, and ADH is the enzyme which is catalyzing the reaction, and NAD plus is getting converted to the NaOH. So meanwhile, there are two other enzymes which are involved, like these are catalase and CYP2A1. Now what these two enzymes are doing here? So the catalase, it is converting H2O2 to H2O. Okay, and it is a side reaction which is happening here. The H2O2 is getting converted to the H2O. Okay, and what is the other side reaction? The other side reaction is the oxygen plus NADPH. It is converted to NAD plus and H2O, and NADP plus and H2O. So these are two side reactions. So as you can see, this is a it is looking like very simple chemical reaction, but in the body when it is happening, so there are many side reactions are going on, and this side reactions, two main side reaction as this catalase and this reaction catalyzed by CYP2E1. So you don't need to know about the details of the reaction, but remember this two important enzymes also. Okay, then what will happen when the acetaldehyde is produced is acetaldehyde, will be converted to the acetate. Okay, and here another NAD plus will convert it to NADH, and ALDH, it will be the ALDH is the aldehyde dehydrogenase, and it will be the enzyme system. Okay, so this was for your problem number 6. And don't worry if you this part is a bit hazy, because when I will share you this PPT uh, directly, you can just check it out from there. It will be clear. Okay, so quickly we will move toward our next problem. Okay, so problem number 7, it says that find out the incorrect statement among the following. Number A, moxifloxacin is a quinolone class of antibiotic drug. Number B, method of action of quinolones is the inhibition of DNA guidase. Number C, doxycycline works by stopping DNA replication. Number D, tetracyclines prevents the binding of tRNA with the A site. So you have to identify about the correct incorrect statement among the following. So this question is related to different class of the drugs like quinolones, like for the tetracyclines and other, and you have to identify which is the incorrect statement among the following. Okay, take a few minutes and try to identify the incorrect statement. So as I have said before, like when there are questions like this, true, false, correct, incorrect, so try to be very careful, because people tend to do little mistake in these questions. Okay, so I myself do sometimes very frequently mistakes for this kind of true, false, or correct, incorrect kind of questions. But for this, you have to just read the question very carefully. If you read the question very carefully, it is there won't be any mistake. That's okay. Let's take 2 to 3 minutes and try to solve this question before I discuss the answer. Do we have any answer for this question? Okay. Okay, I will discuss it. Don't worry. Okay, so the incorrect statement is like number C. Doxycycline works by stopping DNA replication. Okay, so let's read it in the details. So this is the structure of the doxycycline. So the structure of doxycycline is very similar to the anthracycline's drugs which we just read few time back. Okay, this also have 6 member ring joined together, but there is a difference in the structure, because previously we have anthracene kind of moiety here for the B's. If you just name the rings here, okay, so if it is A, it is B, it is C, and it is D. So as you can remember, for the anthracyclines, the B, C, and D ring was a the anthracene ring, and the A ring does not have any double bond kind of thing, but here it is, the things are little different. Okay, somebody wants to join. So this is the doxycycline. Okay, but it is a tetracycline class because it has 4 cycles. Okay, so so this fluoroquinolone structure, and what is the mechanism of action? Okay, so they block the bacterial DNA synthesis by inhibiting bacterial topoisomerase 2 DNA guidase and topoisomerase 4. Okay, the inhibition of DNA guidase. So this is about the quinolone. So as you can see, as I said, that doxycycline is a kind of tetracycline drug. Okay, and the tetracycline how they work. So basically, they binds to the tetracyclines prevent the binding of tRNA with the A sites. Okay, and so in this question we have two kind of class of antibiotic. Okay, so I will highlight. So first is the quinolone class of the antibiotic drug. And the second is the tetracycline class of the antibiotic drug. And this tetracycline kind of drug have this doxycycline molecule, okay? And moxifloxacin is in the quinolone class. So first we will discuss about the moxifloxacin. So moxifloxacin is a quinolone class of the drug. So not only moxifloxacin, there is levofloxacin, ciprofloxacin, okay, ciprofloxacin, and this I think you remember this floxacin, this term, okay. So this term, whenever there is a this term, it will be, you have to remember this is the quinolone class of the drug. So what is the mechanism of action for the quinolone class of the drug? So they block the bacterial DNA synthesis by inhibiting the bacterial topoisomerase 2, the DNA guidase, and topoisomerase 4. Inhibition of the DNA guidase prevents the relaxation of the positively supercoiled DNA that is required for normal transcription or replication. And inhibition of topoisomerase 4 probably interferes with the separation of replicated chromosomal DNA into the respective daughter cells during the division. So this is the mechanism of action for the quinolone class of the compound. Now, doxycycline does not work by stopping the DNA replication. Okay, the DNA replication, it is being stopped by this quinolone class of the compound. So, how this doxycycline or the tetracycline molecules work? So, basically, they actually prevent the binding of tRNA with the A site. So, it is as you can see, this is your ribosomal, so it is a bacterial ribosome where is a with the 50S and the 30S subunit, and we have read it before, I think last to last class about the bacterial and eukaryotic and prokaryotic ribosome. So there are two sides. Okay, the first one is the called the P site, and the second one is called the A site. Okay, so what will happen? Like this tetracycline, they bind to the A site. So what now? What will happen? Like the tRNA will not bind to the A site, and the RNA synthesis will not will be hampered, and the protein synthesis will hampered in this way. So if the protein cannot be synthesized in the bacterial cells, what will happen? The cells will die, and that's how this class of antibiotics works. Okay, so you remember like what is the quinolone class of antibiotic, how they work, and what is the tetracycline kind of antibiotic and how they work. For the quinolone, they inhibit the DNA guidance, thus inhibiting the stopping the DNA replication, and the tetracyclines they inhibit by binding to the tRNA A site, thus it stop the protein synthesis. Okay, and few example of each class, like doxycycline is one of the tetracycline class of antibiotic, and moxifloxacin, levofloxacins, these are the quinolone class of antibiotic. Okay, now we will move toward our next problem. Okay, so problem number 8, it says that identify the incorrect statement of mitomycin C. Number A, it contains an aziridine ring. Number B, it is not a product. Number C, the first step of method of action is the reduction by NADPH. Number D, it forms an indole hydroquinone intermediate. So you have to identify the incorrect statement of the mitomycin C. Take few minutes to answer this question. I will eventually discuss it with you. And during the session, if you have any doubt regarding any problem, any question, you can write in the chat box. Okay. Try to solve the problem number 8. And also you can give me some suggestions, like if it is very fast, I am telling you the things very fast, or should I go some little bit slower. So because we have to finish 20 questions during the 2 hours of the session, so sometimes I go a bit faster, but if you want I can slow down a little bit. So it's all up to you. If you have any problem, anything, you can just write in the chat box. I will take care of that matter also. Okay, anyway, we will let's see what is the answer. So the correct answer is, it is not a prodrug. Now the first thing which we will know, what is a prodrug? Okay. What is a prodrug? So what happen, like sometimes when any drug is given to our body, so it is not a drug itself, it is a prodrug. So what is a prodrug? The prodrugs are the drugs which will convert to the active which will convert to its active mode when it is in our body. Okay. By I think there sometimes there is a breaking of some bond by which it is activated in our stomach or in our bloodstream. Okay. So there are sometimes these are called prodrug. So now why a drug is given as a prodrug instead of the active molecule itself? So sometimes it can be happen like the compound is a very unstable. It is when it is given to the in a tablet form or something. So to stabilize it, it is given in the prodrug from product from, and it will go to our body and it will get activated. Okay, to the actual drug from. So the mitomycin C. So the structure of mitomycin C, it is this. Okay. So this is a mitomycin C. Now, what is the aziridine ring? So aziridine ring is the three-member ring containing the nitrogen. Okay, so as you can see in the structure of this mitomycin, so this part it is called the aziridine ring. Aziridine ring is like this. There is a three-member ring which have the nitrogen. Okay, so as you know, nitrogen heterocycles are very important for the drug discovery in our body. And this I will suggest you to remember what is the name of the every, like there is aziridine. This is the three-member nitrogen containing ring is the this is the called the aziridine. Okay, so there is a aziridine, there is a pyrrole, there are different ring nitrogen containing. So it will be better if you remember this kind of nitrogen containing ring, the names. Okay, so it is the correct answer. It is not a prodrug. It is a so first step of this activation. So basically, this drug, it is a anti-tumor drug. Okay, anti-cancer drug. So how does it works, and what is the method of the action? So it is the your method of the action and the stages where it passes through. Okay, so this is the mitomycin. So this is the mitomycin C. So the first step is the reduction by the NADPH. Okay, so what will happen at the first step? So there is an enzyme called NQO1 reductase, and there is a NADPH or cytochrome P45 reductase. Okay, and what will happen? This is a quinolone ring. So as you can know, this is a your double bond O, double bond O, and it will be reduced to your hydroquinone. This quinone ring will be reduced to the hydroquinone. So there will be OH part. Okay, so this is called the mitomycin hydroquinone, and this reduction is happened by using this enzyme system. Okay, and when this is getting reduced, so what will happen? So there is a formation of the H2O2 and O hydroxyl radical. Okay, so which is cytotoxic. Now what will happen? Like this mitomycin hydroquinone will be it is one methanol molecule is so there is a OCH3 here and there is a hydrogen here. Okay, so there is a hydrogen here. So methanol will be eliminated like this, and we will have this kind of structure which is a indole hydroquinone intermediate. So as you know, this is what is the structure of the indole. As I said you to, it will be better for you to remember the name of the few nitrogenous heterocycles because these are used extensively in the drug. The many drug have the most of the drug having pharmacophore of this nitrogen containing molecule. So this is the indole molecule. And since it has the OH here, so like the hydroquinone formation, so it is called the indolo hydroquinone intermediate. Okay. Now what will happen when there is a DNA molecule? So this DNA will form a adduct with this mitomycin, and it will lead to the cross-linking of the DNA, and that's how this anti-cancer agent work. Okay, by cross-linking the DNA. So this is the method of action of this drug mitomycin C. Now it is sometimes it is very important to learn few method of action of the drugs. Like what happened, like when you are reading about a drug, you are reading about a therapeutic agent for any like antibacterial, anti-cancer and anything. But if you don't know what is the method of the action, it will be very, it is only the memorizing the names and the work. Okay, so that's not how the medicinal chemistry works. Sometimes you need to know what is the method of action, how the molecule is working. That is very important. Only remembering the names and the class of the compound is never enough for the medicinal. How it works, what is the mechanism of action, learning it also very important. Now it is never not like you have to always remember so much everything you have to remember, or so, the common drugs, some mechanism of actions. I think it is better if you learn. Okay, that's how you will remember the answers also, and you will like to read it. Otherwise it is only about memorizing the things, but if you know how this method of action works, how the molecule actually working, what is the reactions involving here, so you will also feel good and by reading these things. Okay, so did you understand this mechanism of action, the pathway which I have discussed here? If not, please tell me right now, I will again repeat it. Okay, so if you did you understood this mechanism of action? Did you understand this? If you have any doubt, just tell me, I will repeat it. So do I need to repeat it? Okay, assuming, I think okay, thank you. So still, if you have any doubt, I will just repeat it once more at the end of the session if you have any doubt. Now we will move to our problem number 9, and it says that which of the following statements is false for secondary metabolites? Number A, they are derived from the primary metabolites. Number B, polyketides is one class of secondary metabolites. Number C, they are directly involved in the growth, development and reproduction. Number D, they are produced in very small quantities. So metabolites in our body, as you all know, it is like two type, primary and secondary, and this question is regarding your secondary metabolites. Okay, and you have to identify the false statement regarding the secondary metabolites. So just like every time, try to answer this. It doesn't matter if your answer is correct or wrong, because but if you try, just try answering this. So which statements is false about the secondary metabolites? Number A, they are derived from primary metabolites. Number B, polyketides are one class of the secondary metabolites. Number C, they are directly involved in the growth, development and reproduction. And number D, they are produced in very small quantities. So what do you think is the correct answer? I mean, what is the false regarding the secondary metabolites? So do we have any answer? Okay, so we have three answers, or we have two B and one C. Okay, let's see what is the correct answer. So this is good, like you are responding, because okay, so let's see. So the correct answer is C. I mean the first statement regarding the secondary metabolites. So they are directly involved in the growth, development and reproduction. This statement is false. Okay. So what are the secondary metabolites? So secondary metabolites are the compound which are derived by the pathways from primary metabolic routes. They are not essential to certain life of the cells. These compounds do not have a continuous production. Very often, secondary metabolites are produced during non-growth phase of the cells. Secondary metabolites are the end product of primary metabolites such as alkaloid, phenolics, steroids, essential oils, lignins, resins, and tannins, etc. So what are the differences between the primary metabolites and secondary metabolites? So primary metabolites perform a physiological functions in the body like intrinsic functions, but secondary metabolites are derivatives of the primary metabolites. Primary metabolites, they directly involved in the growth, development and reproduction, but the secondary metabolites, they play a role in the ecological function. Primary metabolites are formed during the growth phase due to the energy metabolism, and the secondary ones, they formed near the stationary phase of the growth. The first one, they produced in the large quantities and the extraction is very easy. But the secondary metabolites, they are produced in very small quantities and their extraction is thus very difficult. The primary metabolites are same in all plants, but the secondary metabolites are unique for the different plants. Okay. The part of the basic molecular structure often, the primary metabolites are a part of a basic molecular structure of an organism. And the secondary metabolites, they are not a part of the basic molecular structure of an organism. The primary metabolites like ethanol, lactic acid, nucleotides, vitamins are the examples. And pigments, antibiotics and drugs are the example of the secondary metabolites. So this was all about your primary metabolite and secondary metabolite. Okay. And this is very easy. I think this is a little bit, confusing. It might be, but it is relatively easy about primary and metabolite, secondary metabolite. Okay, now I will move toward the problem number 10. Okay, this is an interesting question. So it says that which of the reaction following is involved in the method of action for the calcisamine. Okay, calcisamine. So the options are like this. Number A, Valley-Silman reaction. Number B, Suzuki coupling. Number C, Diels-Alder reaction. And number D, Boltzmann cyclization. So this is also a very important natural product, okay, and this is also anti-cancer drug. So there is a important name reaction which is involved in the method of action of this molecule. So as I said, like when you are reading about medicinal chemistry, only knowing some diseases names and their medicines, their drugs is not enough. Okay, it is very important to know some method of actions and some reaction, how the molecule work, the drug is working. So it is also very important. So try to answer this question. If you cannot answer, it is okay. I will discuss it in detail. But first, you try to answer it. If you know it, you can answer it in the chat box. If you don't know, it is again fine. Okay, I will show you this answer first and then we'll discuss it. The correct answer is the Boltzmann cyclization. So first, this is also anti-cancer drug which is acts on DNA. Okay, so Boltzmann cyclization, it is basically a radical reaction. So what happens in this reaction? First, see in this place. So what happens? There are indienes. So what is indiene? Indienes means there is this in means so indienes in and then indienes. Sorry, I have just made a mistake. So what this term mean in diene? So this means double bond, this in, and this ine, it means triple bond. So this indiene structure means there is a triple bond, then single bond, then double bond, then single bond, then triple bond. So there are two triple bonds and one double bond. So what happened? These triple bonds are getting radically cleavaged by heat or H nu means light, and 1,4-benzene diradical is formed like this. Okay, and what happened? Like this diradical takes the hydrogen from this kind of moiety, and the cycloaromatization happens. Okay, and what happens by the cycloaromatization? This kind of molecule is formed. Okay, from this indiene we have this benzene kind of the structure with this pathway. So this mechanism, it is called the Boltzmann cyclization mechanism, which is a radical cyclization. Now look at carefully at this structure. So this is the structure of calcimicine and it is the anti-cancer drug. So how it works? So as you can see, this is the structure. It has this indiene structure. So there is a triple bond here. Then there is a, okay, let me use the laser pointer. So there is a triple bond here, then there is a followed by a double bond, and there is a again triple bond. There is a O sugar moiety, and this is the complete structure. So as you can see, there is this kind of structure. So what happened, the first step is the nucleophilic attack on this sulfur moiety, and when this is nucleophilus attacks here, this sulfur sulfur bond is breaking, and this is one proton is taking, and this is a thiol kind of group. Okay, now what will happen, this thiol, it will attack on this your um, conjugated dione type of thing, so conjugated ketone type of thing. So it will attack here, this double bond will go there, and this oxygen will form a negative charge here. So we will have this kind of moiety. Now what happened, the next step is the Boltzmann cyclization step. So what will happen, the Boltzmann cyclization will take place, and this indiene will form this kind of benzene ring with a diradical. So what will happen with this diradical, and the DNA, it will this diradical will take the hydrogen from the DNA, and DNA diradical is formed. And what will happen, in presence of oxygen, the DNA double strand cleavage will happen. So that's how it destroys the DNA of the cancer cell, and it acts as an anti-cancer agent. So as you can see, the main mechanism is Boltzmann cyclization. But how interestingly, like we know this chemical reaction, but how in this method of action of this natural product, it also take place. Okay, so this is the mechanism of action. So just take a look carefully at this mechanism, and also I am giving you a break for 2 minutes. Okay. Okay, sorry. So, okay, one second. Okay, so I will give you a 2 minute break. So you look at the mechanism carefully. Okay, after 2 minutes, I will then continue the rest of the questions. We have completed 10 questions right now. We have 10 more to solve today. So let's take a 10 minutes. Sorry, not 10 minutes. Let's take a 2 minute break, and then we will discuss the rest of the question. And meanwhile, look at the mechanism carefully. And if you don't understand the mechanism, tell me after the break. I will just repeat it once more. Okay, so I will just taking these things off. Okay, I am here, but I am keeping my camera and microphone off, and just take a 2 minute break. We will join sharply at 7:04. Okay, so just look at the mechanism carefully, and let me know if you don't understand the mechanism. Okay. Hello. So I'm back. So my voice is audible. Hello. Somebody confirm, like if my voice is audible or not. And have you guys? Okay. So I think you have take a good look. Have taken the good look for this mechanism. So do you have any problem understanding the mechanism, how the molecule works? If you have any problem, if you not have not understood this, tell me right now. I will repeat it once. Okay. So did you understood this molecule, how this molecule is working, how it is cleaving the DNA and what is the mechanism is involving here? Okay, so I will move toward our next problem then. This is very easy actually. This molecule is seeming like very complicated, but when I will share you this PPT, if you read it once again, so you will understand that this is very easy molecule. I mean the mechanism is very easy. All the reactions you know, all the reactions you have studied in your organic chemistry courses, and it is just an application of all those chemical reaction which you have learned in the normal drug discovery and biology system. Okay, so quickly we will move toward our next problem. So the problem number 11, it says that which of the following statement is untrue regarding cisplatin? Number A, chlorine groups are displaced before the drug becomes active. Number B, intrastrand cross-linking of DNA result from the action of the drug. Number C, base pairing of adenine and guanine is disrupted by this. Number D, it has a square planar geometry. So identify the untrue statement regarding cisplatin. Try to answer this question in the chat box. It does not matter if your answer is correct or incorrect, because you all are learning here, but it is very important for you to try. Otherwise I won't be able to know if you have understood these things or not. So is there any correct answer? Okay, try to find out the untrue statement regarding cisplatin. Do you have any correct answer? Okay, do we have answer like C, number C? Okay, let's see. So like this is important, like you respond in the class. Okay, so the correct answer means the untrue statement regarding cisplatin is number C. The base pairing of the adenine and guanine is disrupted by this. Okay, so let's see now what is cisplatin and how it works. So this is the compound which is called the cisplatin. Okay, and this is something called the transplatin. So what is the cisplatin? So the cisplatin have the platinum in the middle, and it has a square planar geometry where in the four corner there are two amine groups in one side and two chlorine group in other side for the cisplatin, and for the transplatin we have this groups trans to each other. So the now look at the carefully the mechanism of action. So what happened? Like in the plasma membrane, so in the blood, the chloride ion concentration is very high. Okay, so it is like 104 millimolar in the blood. So what happened in the blood? The cisplatin stays as normal, but what happened when crosses the plasma membrane, and it is it have reached in the cytoplasm. So in the cytoplasm the chloride ion concentration is very low. It is like only 4 to 10 millimolar concentration. So what will happen? This chloride groups are displaced by the water molecules. Okay, so now what will happen? This cisplatin molecule, it will form a hydrogen bonding with the so this is a cytosine and the cytosine and guanine hydrogen bonding in the DNA. Okay, now the cisplatin, it will bind to the N7 of this of this guanine ring, and what will happen when it is binding there? It will like this 1,2-D GPG inter strand adduct. So it is a major adduct which is formed, and because of this adduct, this it will rupture this hydrogen bonding and this DNA. Okay, now if you look at the statements carefully, you will know. So the first question, it says that the chlorine groups are displaced before the drug became active. So it is true. The number B, interest and cross-linking of DNA is results in the action of the drug, which is also true. As you can see at the last stage, there is a interest and adduct formed with the cisplatin and the DNA. Okay, number C, the base pairing of adenine and guanine is disrupted by. So this is something which is wrong. So the base pairing, first of all, adenine and thymine, they are actually take place in the base pairing, not adenine and guanine. So cytosine and guanine, they take part in the base pairing, and this molecule, it forms binds with this N7 of this guanine, and that's how this mechanism of action is happening. So number C is untrue, and number D, it is also true. It has a square planar geometry. So this is all about cisplatin, how it works. And when the transplatin, it is not active at all because it has this chlorine groups trans to each other, and if it is displaced by this, so water molecule will be trans to each other. So this so that's how this kind of adduct will not be formed. Okay, now we will move toward our next problem. So problem number 12, it says that the cofactor for the conversion of acetyl CoA to malonyl CoA is number A, NADP, number B, biotin, number C, ADP, and number D, TPP. So you have to identify the cofactor for the conversion of acetyl CoA to malonyl CoA. So this acetyl CoA, it is a very important molecule for our body, and this things, and the reaction related to this acetyl CoA and everything, it is very important for you to learn and to know. So try to answer this. What is the cofactor for the conversion of acetyl CoA to malonyl CoA? Take a few minutes and try to answer it. So when you are learning from the for this course, always try to learn few more things, which is not only in the lectures or only in the previous year's questions. So it is important to try to learn some different questions also sometimes, because that's how you will learn the medicinal chemistry course a little better. So I always try to give some few other out of, I mean, question which is not directly involved in the previous year's question, but the topics are same, but the questions are a little bit different from the previous years. Okay, so that's how you will learn the course more better. So it is fine if you cannot answer the questions if it is unknown to you, but after I show you the answer, you will read about this more. Okay, so I will show you the answer. So the correct answer is the biotin. So this is a very simple reaction for this conversion of this acetyl CoA to malonyl CoA. So acetyl CoA, it is a very important coenzyme in our body. Okay, so this acetyl CoA is converted to malonyl CoA. So look at this reaction at first. Okay, now, so this acetyl CoA, what happens, like, so in the malonyl CoA, so one hydrogen, it is actually replaced by this carboxyl type of group. So from where this carboxyl type of group is coming from? From the carbon dioxide. Okay, and the cofactor is the biotin, and the enzyme, it is the acetyl CoA carboxylase. And in this process, one ATP molecule is converting with the ADP plus PI, and that's how the energy is coming from this. And this is the overall reaction. Now this reaction is very simple. Like when you are actually facing this kind of problem, sometimes what happen, like these names are very pretty hard, like acetyl CoA, malonyl CoA, and you think what is kind of this reaction, how it is happening. But the reaction, as you, if you see the reaction and the structures, it is a very simple reaction. One hydrogen is replaced by this carboxyl group. This carboxyl group, from where it is coming, it is coming from this carbon dioxide. And biotin, which you have to remember, this biotin is the cofactor for this conversion, and the enzyme is the acetyl CoA carboxylase. Okay, this is the overall reaction. So I will move toward our next problem. Problem number 13, it says that which of the following statement is true regarding the antibodies. So antibodies, antigens, these are some different things, and which is in your course, but I have not seen any I mean detailed question regarding this antigen and antibodies in your previous years. But let's try this understanding this antibodies and antigens better. So what is the statement is true regarding the antibodies? Number A, T cells are associated with the humoral immunity. Number B, B cells are associated with the cellular immunity. Number C, B lymphocytes are present in the bone marrow. And number D, B lymphocytes are generated by the thymus. So this B T cells, B cells, B lymphocyte, T lymphocytes is all related to your antigen and antibody things, and these all are actually related to our immunity. So there are two types of immunity, which one is humoral and one is cellular. So try to answer this question. If you know, you can answer this question in the chat box. If you don't know, it is okay. We will discuss it in detail, so you don't have to worry. Okay, we have one answer C. Okay, good. We have common answer C. Others also try. So we will, let's see. Okay, very good. Correct answer is C. B lymphocytes are present in the bone marrow. So lymphocytes are actually antibodies. So these antibodies, they are actually related to our immunity. So there are two type of two type of antibodies in our body. First is B lymphocyte and other one is the T lymphocyte. So this is a very interesting picture which is easy to remember. So what does B lymphocyte do and what T lymphocytes do? So B sites, they attack the invaders outside the cells. Okay, so what happened, like if you have your body, there is any contamination, there is any foreign particle, so this B cells, what they will do, they will attack those foreign particles directly outside the cell. Okay, what the T cells do, they do not attack the contaminants or the foreign particles directly, rather they will attack the infected cells, so that this infected cell do not infect the other normal healthy cells. Okay, so this is the basic difference between the B cells and the T cells. The first one, they attack the invaders outside the cell, and the second one, they attack the infected cell directly. So this B lymphocytes and T lymphocytes, there is some I mean, the differences on there is something. So let's see. So the B lymphocytes, which attack the invaders outside the cell. So the origination and the maturation takes place in the bone marrow. And the for the T lymphocytes, the origination in the bone marrow, but the maturation in the thymus. Okay, so what happened, like this B lymphocyte, they originates and became mature in the bone marrow itself, but the T lymphocytes, they originates in the bone marrow, but they get matured in the thymus. Okay, now they differentiate into plasma cell. The B lymphocytes differentiate into plasma cell. The T lymphocyte, they differentiate into plasma cell or the memory cell or the cytotoxic T cells. The B lymphocytes, they are involved in the humoral immunity, and the T lymphocytes, they are involved in the cell mediated immunity. And the first B lymphocytes, they produce antibodies, and the T lymphocytes, they help B lymphocyte to produce antibody. So these are the all about the B lymphocyte, T lymphocytes, and about the antibodies. Okay, so I think you've understood what is B cells and what is T cells and how does they work. So this was all about your antibodies. Now quickly I will move toward our next problem. So next problem, it says that how oxalidione works. Again, we have actually learned about the quinolone class of compounds in the previous one question. Okay, so okay, let's see first check out the answer. So how oxalidione works? The options are number A, it inhibits the protein synthesis by binding to 30S ribosome. Number B, it inhibits the protein synthesis by binding to 50S ribosome. Number C, it unwinds the DNA double helix. And number D, it inhibits the DNA guidase enzyme. So oxalidinones, like we have learned about the quinolone class of compounds and tetracycline class of compounds just a few questions back. So these all are this kind of this antibiotics. Okay, so this mechanism of action of this antibiotics are something different. Like you have said, we have seen like how the quinolone works. Okay, so they actually works on the DNA guidase enzyme. How the tetracycline works? The tetracycline inhibits the protein synthesis by binding to the A site, okay, of the ribosome. Now the oxalidinone, you have to identify what is the correct mechanism of action, how it works. So this is when you are learning about this kind of class of compound, class of drug. So these three things are very important. One is the basic structure of or the pharmacophore of that particular class of compound. Number two, few example of this compounds, and number three, the method of action. The broad method of, not the detailed one, but how it works, just you have to know it. Okay. So try to answer this question. If you know, you can write it in the chat box. If you don't know, it is fine also, because as always I will discuss it in detail. Okay, we have one answer, number B. Okay, let's check out if it has. Okay, others also try uh, about how the oxalidione works. If you learn like this, the medicinal chemistry, if you learn like this, how what is the compound, how it looks like, how it works like. So, okay, so that's how you will find it interest. Otherwise, it is only about like memorizing names of some drugs and some compound, but that's not how you will enjoy learning this. So it is always better. Okay, we have only an answer B. So let's check out what is the correct answer. Okay, very good. The correct answer is number B. It inhibits the protein synthesis by binding to 50S ribosome. So, as I said, always it is better for you to when you are learning a class of compounds, how it looks like, what is the broad structure, okay, the basic structure, and the method of action, and few examples. So for oxalidinones, the examples are linazolid, radifusolid, and torazolid. So these are the examples of this oxalidone class of compounds. So linezolid is totally synthetic antibiotic. They are active against the gram-positive organism, including staphylococci, enterococci, gram-positive anaerobic cocci, and gram-positive rods, such as some bacteria, okay, and microorganisms. So the method of action is it inhibits the bacterial protein synthesis by binding to the 50S ribosomal subunit near the interface with the 30S subunit. Thus, the formation of the initiation complex is prevented. Okay, so as we learned in a previous one, like one second, I will show you. So in previous one slide we learned about, so this is the bacterial ribosome. There is a 50S and 30S. So the oxygen they bind in this interface, okay, the 50 interface of 50S and 30S, mainly near the 50S, and that's how it inhibits the protein synthesis. Okay, so this is the class of the core structure of the oxaliridone, this antibiotic. So why it is called so? So as you can see, this core structure, this 5-member ring with this nitrogen, oxygen, and double bond oxygen, this is called a oxazolidinone. Okay, so this is the oxaliridone, and there is an with nitrogen there is a benzene ring, and with this structure we have the side chain. Okay, so by changing this side chains and by incorporating various substituent, many the compounds are generally formed. And so there is a role of every ring. Okay, so as you can see, like ring A. So this is the ring A, which is the core ring, which is the oxygenidone ring. So it interaction with the peptidyl transferase center PTC of the 50S ribosome subunit. The side chain, which is the side chain, this red one is the side chain. So what does it do? The hydrogen bond with the phosphate group on a residue of the upper part of the PTC. Okay. So ring number B, this pink one. So they interact with the PTC. The PTC is the peptidyl transferase center by the pi stacking. Ring number C, this green one. So how does they work? The modulation of the pharmacokinetics. Okay. And ring number D, so there sometimes there is a ring number D also. And what does this ring number D is this one, the side chain. They improve the lipophilicity. Okay, so this was all about the oxygenidone. So this is the basic structure, and this is there is a detailed role of every structure and every subunit, every ring. Okay. So this was your problem number 14. Quickly, I will move toward the problem number 15. This is also a very important and interesting question. So which of the following is known as the antigenic determinant? Your options are hapten, epitope, enzymes, and paratope. So what is known as the antigenic determinant? So try to answer it. Which of the following is known as the antigenic determinant? In the last question we read about the antibodies. Now it is time for the antigens. What is the antigens and what is the antigenic determinants? So what is the antigenic determinant is known as? It is hapten, epitope, enzymes, or paratope. Try to answer it. We will discuss each and every options, which is what. But at first you try it yourself. If you know, you can try to answer it. If you don't know, it is fine. I will discuss it anyway. So do we have any answer for this? Okay. Okay, let's check out the correct answer. Okay, so epitope. The epitope, it is called as the antigenic determinant. Okay, so first we need to know what is the antigen and antibody. Okay, and what is the epitope and what is all about. So first let's take a picture of this. So this is the antibody. This green and this yellow thing, it is the antibody and it is the antigen. So in the antigen there is a something called antigenic determinant. Okay, this some functional group. And in the antibody there is also some kind of this structural formation which is called the paratope. This epitope and paratope, they form this antigen antibody complex mainly. Okay, so this antigenic determinant is known as a epitope, and the where it is binding in the antibody, the place is known as the paratope. Okay, so hapten, what is hapten? Hapten is a molecule too small to stimulate antibody formation by itself. However, when the hapten is combined with a larger carrier molecule, usually a serum protein, the hapten and the carrier together form a conjugate that can stimulate the immune response. Okay, so this is all about hapten, and since this is the hapten molecule, this small molecules, okay, so these molecules are too small to simulate antibody formation itself, but when it is forming a conjugate with a carrier molecule, this hapten carrier conjugate is formed, and this conjugate can stimulate immune response. Okay, and what is enzymes? Enzymes are actually it is from antibody and enzyme together. So these enzymes are often called catalytic antibody. Is a monoclonal antibody with catalytic activity. So when the monoclonal antibody has some catalytic activity, is called the enzymes. Okay. So epitope is known as antigenic determinant. Is a part of an antigen that is recognized by the immune system, specifically the antibodies, B cell, T cells, and paratope. Paratope is a part of antibody which recognize the antigen and the antigen binding site of the antibody. It is a small region 15 to 22 amino acid of the antibodies, every region that contains part of antibodies heavy and light chains. Okay, so this is a paratope and epitope. Epitope is the antigenic determinant part of antigen, and it is recognized by immune system like antibody, B cell, T cell, and paratope is a part of an antibody which recognize the antigen and antigenic binding site of the antibody. Okay, so this is a small region of 15 to 20 amino acid. So this was the antigen and antibody things. Now we will move toward our next problem. So problem number 16, it says that identify the correct statement regarding the following. Number A. Acetyl-CoA is the thioester of coenzyme A and acetic acid. Number B. Pyruvate is starting point of the synthesis of the acetyl-CoA. Number C. Pyruvate is formed by the metabolism of glycogen. And number D. TPP or thiamine pyrophosphate participates in the acetyl-CoA formation. So as I have said before, like acetyl-CoA is a very important molecule for our body. Okay, and you need to know about this acetyl-CoA because during the medicinal chemistry course, very often I mean see about this molecule. So try to identify the incorrect statement among the followings. Okay, do have anybody answer it? Okay, so no problem, we will discuss it in detail. Okay, so the correct answer is number C, means the incorrect statement regarding the following. Pyruvate is formed by the metabolism of glycogen. So it is the incorrect answer. So as I said before, like acetyl-CoA is a very different, I mean important enzyme in our body, part of our body. So acetyl-CoA, this is the structure of the acetyl-CoA. Now this structure, this which is shown in the black, it is your coenzyme A. Okay, and again I have said you don't need to memorize the structure of this complicated molecule, but this part is important. Okay, so it is actually a thioester of the acetic acid and coenzyme A. So as you can see, this is the part in the black, it is your this part is your coenzyme A, and this bluish part, it is comes from the acetic acid, and this is called a thioester. So we know the ester is like, so acetyl CoA, it has actually the coenzyme A, it has actually the side chain of this thiol like SH. Okay, and when it is it is reacting with the acetic acid, it forms this kind of thioester which is known as acetyl CoA. Okay, and the pyruvate is the starting point of this starting point of its synthesis of acetyl CoA A, and TPP, it is also a coenzyme which is a thiamine pyrophosphate. It participates in the acetyl CoA formation. So remembering these few things of acetyl CoA is right now it is enough. Okay. So next question. So it says that dihydroxyacetone phosphate is rapidly and reversibly converted to number A, glyceraldehyde 3-phosphate, number B, 1,3-bis phosphoglycerate, number C, fructose 1,6-bis phosphate, and number D, fructose 6-phosphate. Try to answer this question. So dihydroxyacetone phosphate, it rapidly and reversibly converted to what? So, have anybody answered it? So we have one answer, option number A. So let's check out. Okay, so yeah, good. So option A is the correct answer, glyceraldehyde 3-phosphate. So this is the reaction for this. Okay, we will just use it as a pointer. So first, this reaction starts with the 3-phosphoglycerate. So this is the 3-phosphoglycerate. And what will happen? This 3-phosphoglycerate, with the help of the phosphoglycerate kinase, so it will convert it to 1,3-bisphosphoglycerate. Now we all know kinase. What does kinase do? It takes up one phosphate from the ATP, converts it into the ADP, and incorporates in this phosphate to this phosphoglycerate molecule, and the phosphoglycerate is converted to 1,3-bisphosphoglycerate. Now the next step is this 1,3-bisphosphoglycerate, it is converted to glyceraldehyde 3-phosphate by the help of this NADP glycerine aldehyde phosphate dehydrogenase enzyme. Okay, and this is the side reaction where the NADPH H plus and converted to NADP plus. Okay, and the phosphate, one phosphate is coming out from this molecule. Now this glyceraldehyde 3-phosphate, it is converted to dihydroxyacetone phosphate, and this is these two are the triose phosphate. Okay, triose because it has 3 carbon, and the triose means like it is a sugar kind of carbohydrate kind of molecule, because it has a that's why it's just 3 carbon. This is why it's called the triose phosphate, and this is the enzyme which is is involved in this reaction is the triose phosphate isomerase. Okay, and diglyceraldehyde 3-phosphate is converted to dihydroxyacetone phosphate, and this reaction is rapid and also reversible. Okay, so as you can see, like this is the isomerism reaction because it has the aldehyde group here and alcohol group here. Just this 2 carbon takes part in this isomerization, and this aldehyde is isomerized to this alcohol and this alcohol to the ketone group. Okay, and this part is normal. I mean, this part is unchanged, and only this carbon the isomerization takes place. And the enzyme is like triose phosphate isomerase. So the question can be given to you like this, like the dihydroxyacetone is rapidly and reversibly converted to glyceraldehyde 3-phosphate. Write the name of the enzyme which is involved here. So the name will be triose phosphate isomerase. Okay. So now we will move to our next problem. So the next problem number 18, it says that the acyclovir, the structure is shown below. It is an inhibitor of DNA polymerase, and this is selectively in the virus infected cell. So this is because number A, acyclovir is first converted to the monophosphate by the viral thymidine kinase. Number B, acyclovir does not enter infected cells. Number C, it is first converted to monophosphate only by the host thymidine kinase. And number D, acyclovir triphosphate is not accepted by host DNA polymerase. So this is a very important drug for as an inhibitor of DNA polymerase for the virus infected cells, especially in the HIV kind of diseases. So you have to identify why it actually selectively infects the virus infected cells. The DNA polymerase of the virus infected cells is selectively inhibited by this molecule. Why? So read the options carefully. I think by reading the options carefully, you will able to answer this question easily. Do you have any answer for this question? Okay, it's okay if you like, you can try. So I will show you the answer. So the answer is number A, acyclovir first converted to monophosphate only by viral thymidine kinase. So I have told you, like, read the options carefully. So sometimes the options, if you read the options carefully, if you don't even know the answer, but you can just guess how it will what is the correct answer. So you see, so it says that it is an inhibitor of DNA polymerase selectively in viral infected cells. Means this molecule, it only will attack the DNA polymerase of the virus infected cell. So there must be any reason for it, right? So acyclovir, it is actually a prodrug. Like I have said you before, like what is a prodrug? Prodrugs are not an active form of the drug. So it will be converted in the active form of the drug in the your specific area where it will act. Okay. One second. So since it is a prodrug, what will happen? It will first convert it to its active form. So why it will be, how it will be converted? So it will be first converted to monophosphate. So as you can see, there is a alcohol group. Okay. So it will be converted to a monophosphate only by viral thymidine kinase. Okay. So as we know, the role of the kinase is to uh, transfer one phosphate group from ATP, and ATP will be converted to ADP, and one phosphate group will be transferred to the alcoholic group. Okay. And only viral thymidine kinase will able to convert this molecule to the monophosphate. Okay, by converting, by taking the phosphate from ATP. Okay, so what will happen? Like, or if only the viral kinase can convert this molecule to the active form, so it will only selectively inhibit the virus infected cells, because only virus in kinase enzymes are converting this prodrug to the active form of drug, not the host thymidine kinase. So when you are giving a drug for the virus infected cells, so there are normal cells also. Okay, so if the normal cells kinase, which is the option number C actually, so if the normal host cell kinases are also taking part in activating this molecule, so it will also destroy the normal host cell, right? So that's how it works. That's why some drugs are needed to be given as a prodrug, not as a I mean active drug. Because if it is giving as the active drug, if it is giving as the only monophosphate form, what will happen then? It will also kill the normal infected normal cells, but it won't, because it is giving as a prodrug, and it will be converted only by the viral thymidine kinase. Okay, so we will move to our next problem. Okay, then again we have some question from the acetyl CoA. So it says that what is the correct set of enzymes involved in the biosynthesis of acetyl CoA? The options are TPP, FAD, NADH. Option B is TPP, lipoic acid, FAD. Number C is FAD, NAD plus and lipoic acid. And number D is lipoic acid, NADH and TPP. You have to identify the correct set of coenzymes which are involved in the biosynthesis of acetyl CoA. So as again, acetyl CoA is a very important for your medicinal chemistry course, and you have to know like how it is produced in the body. So we have very less time remaining in our class. So I will check first in the chat box, and I will quickly show you the answer and we will discuss it. It is a different question, I think. Okay, so the correct set of answer is TPP, lipoic acid and FAD. So conversion of the biosynthesis of the acetyl CoA. So in the previous one question, I have shown you like this acetyl CoA. It is synthesized from the pyruvate. Okay, so the pyruvate, it is converted to the acetyl CoA, and this reaction. So this is the complete reaction. Okay, and as I have shown you, like biotin is the I mean biotin is involved also in it. The from the pyruvate to vanillin, this biotin is involved again. So now the lesser point. Okay, so the net reaction, it is the oxidative decarboxylation reaction of the pyruvate. So this pyruvate, it is the oxidative carboxylation happens, means one carbon dioxide molecule is eliminated from the pyruvate, and this acetyl CoA is formed. So there will be a coenzyme A, as I have shown you, like there was a thiol group, right? Coenzyme A, it has a thiol group, and then what happens? Like it is working, I mean taking part with the reaction with this pyruvate, and this acid group, it is forming the thioester with this acetyl CoA with this coenzyme A, and NAD plus TPP lipoic acid and FAD. This are taking place. These coenzymes are involved in the biosynthesis, and the enzyme which is involved is called the pyruvate dehydrogenase. Okay, and it is a very complex reaction. And as you can see, the delta G negative is the minus 33.4 kilojoule per mole. And okay, so this where does these things are derived? Okay, so the TPP, it is derived from the thiamine, which is vitamin B1, and FAD, it is derived from the riboflavin, which is vitamin B2, and NAD, it is derived from the niacin, which is B3, and coenzyme A, it is from the plantothenic acid, which is vitamin B5. So the as you can see, like this biosynthesis of acetyl CoA in our body, it is highly dependent on the vitamin B complexes. Okay, so vitamin B complexes are very important because these coenzymes are derived from these vitamins. So to require total 5 coenzymes are required. And TPP, lipolite, FAD are for the prosthetic groups, and NAD plus and coenzyme are the substrate. Okay. Now the last question for today's session is, it says that which of the following statement is false regarding the ascorbic acid? Number A, it is a strong antioxidant. Number B, it catalyzes the hydroxylation reaction. Number C, it is produced inside the human body, it is not required through diet. And number D, it chelates with iron to make it more soluble. Now ascorbic acid, regarding, as we all know, it is one vitamin actually. So I think you should know about what is ascorbic acid, and you can try to answer this question. Which statement is false regarding the ascorbic acid? So number A, it is a strong antioxidant. Number B, it catalyzes hydroxylation reaction. Number C, it is produced inside human body, not required through diet. And number D, it chelates with the iron to make it more soluble. So do you have any answers for it? Okay, so no problem, I will just discuss it. Okay, the false statement is, it is produced inside our body, not required through diet. So this is the ascorbic acid. So ascorbic acid, it is a very strong antioxidant. As we all know, the name of the ascorbic acid, which vitamin is the ascorbic acid? So it is the vitamin C. Okay, so vitamin C, it is the structure of the ascorbic acid. So this does not it is not produced in our body. Okay, we must require it from our diet. As we all know, like citrus fruit, like lemons, orange, and this kind of citrus fruits have this ascorbic acid, and the deficiency and the deficiency signs of this vitamin C is the scurvy, and for the gum bleeding and everything. And vitamin C also is a very ascorbic acid is a very strong antioxidant because it catalyzes the hydroxylation reaction in our body, and it is a very strong antioxidant because we all know it is related to our immunity. Like for the strong immunity, we are said to have the citrus fruit contains vitamin C containing fruit, and sometimes if you have some viral infection or cold, you are given vitamin C supplements also. And actually it chelates with the iron to make it more soluble. Now it's sometimes said like when you are taking the vitamin C and iron, so it is to make it more soluble, you need the vitamin C. So when you are taking iron or you have iron deficiency, you have also should check for the vitamin C deficiency, because it actually makes iron more soluble in our body to absorb. Okay, so this was all about today's session. So thank you. Now if you have any question, any doubt. Okay, the first question. Okay, I will repeat the first question, no problem. Okay, so the first question, it was related to the Vinca alkaloids. Okay, so these are a class of alkaloid or natural product which are the actually these Vinca alkaloids are class of the natural products which acts as a anti-cancer drugs. So what happened, like in the normal cells, normal mitosis, the cell division, what will happen, there is a phase called metaphase. Okay, in this metaphase, the chromosomes are getting divided. Okay, and the tubulin molecules are formed. from this and this microtubule, the tubulin molecules from the microtubule, and they stack to form a mitotic spindle, and then the cell goes to the anaphase. But if there is a Vinca alkaloid present, what will happen? They will form the they will bound to the tubulin dimers, and the paracrystalline aggregates will form. Now, for this paracrystalline aggregate, what will happen? Like this mitotic spindle will not form in the from the metaphase, and the anaphase cannot take place because the disruption of the mitotic spindle will happen because of this paracrystalline aggregate, and the cell will die. Okay, so this basically this alkaloids acts on the cancer cells only, and it actually hampered the cell division of the mitosis of the cancer cells. Now there is one thing, like in our body, so there are cancer cells. So when we are giving some compounds as anti-cancer drugs, so what happens? It can also act as a normal cells of the body, right? So what will happen? Like if we have in the body the cancer cells are normal human cells, they have some characterization difference. Okay, so cancer cells, like it pH is different from the normal cells. Okay, so there is some difference like pH, and there are many other differences of the cancer cell and normal cell. I will discuss it in some time when there is anti-cancer drugs in your course. So what happened? Because of that differences are actually mainly targeted by the anti-cancer drugs. Okay, so if the differences are not targeted, what will happen? You are giving one compound for the cell death of the cancer cell, but your normal cells are dying, so it should not be happening, right? So that's how the anti-cancer drugs are designed. And today actually we discussed many questions which are not in your previous year course, previous year quiz question or assignments. So I try to incorporate some different questions, because if you are learning some different thing, it is good for you too. Okay, so I think that's what it's for today. So I think I hope you liked the session, and if you have any suggestions, so you can just feel free to tell me the suggestions. Okay, today it was the week 4 live session, and we discussed about your week 5 course contents. Okay, and mainly it was all about anti-cancer drugs, the drugs which target the nucleic acid, especially the DNAs, and how the class of the drug works. Okay, so we learn about these things. So next session, it will be the week 5 session, where we will discuss the your week 6 course content. Okay, and every Saturday we have this kind of class from 6 p.m. to 8 p.m. Okay, so if you have any doubt, anything regarding today's session, or today's questions or topics, anything about, you can tell me in the next session. This slide PPT and this lecture video, it will be communicated to you by the NPTEL website. I will upload it, I will share it with them, and they will communicate to you. And okay, so that was it. Thank you for joining. I hope you enjoyed learning today's in today's session, and I will see you in the next day. Okay, so thank you. Thank you all. I will close today's session. If you have any doubt, we can discuss it in the next day. Thank you.